Something naturally incompatible with the flat Earth from the very beginning is the gravitational force. This is of course because gravity predicts that any object greater than a few hundred kilometers in diameter will naturally collapse into a sphere. This is a problem for the flat Earth because if gravity was applied, it would instantly begin to collapse into itself as everything in it flew towards the central North Pole and formed the shape of a sphere. Therefore, the flat Earth community has consistently denied the existence of gravity, which of course is a very big problem, because gravity, being both a law and a theory, means it explains the world around us like nothing else can. Not only that, but of course denying gravity creates a multitude of problems when the real world is observed. Many flat earthers have cited the force of buoyancy as the explanation for why things fall, giving the example of hot air balloons flying into the sky and seemingly defying the laws of physics. But of course, they aren't defying the laws of physics, and saying that buoyancy is a replacement for gravity is fundamentally wrong. Buoyancy is a force that acts against gravity, and its equations are not the same as gravity's for very good reasons. For one thing, objects floating in the same solution will rise and fall at different rates, depending on what substance they're made of. That's why adding more heat to a hot air balloon will make it rise faster. However, in the real gravitational world, disregarding air resistance of course, all objects fall at the same rate no matter what material they're made of. However, the most basic problem is that buoyancy is fundamentally dependent on the pressure of molecules. A boat can only float because of the water beneath it, and a hot air balloon can only rise because of the air around it. However, if buoyancy were the only force, then in a vacuum objects would appear to simply float around with no force acting upon them at all. However, when we place objects in a vacuum chamber, such as the large ones owned by NASA, objects still fall at the exact rate predicted by Einstein's general theory of relativity. However, the equations for buoyancy don't even apply. However, at its most fundamental level, buoyancy can only explain the motions of objects within a system, but it cannot explain the motion of the entire system. For example, if gravity were not present, then there would be no force to hold on to the thin upper atmosphere, and one by one the denser and denser layers of our atmosphere would fly into space. But we can thank gravity that doesn't happen.